going to work on a couple of exercises from Chapter 8. Now, in Chapter 8, you were introduced to two more connectives. Recall that the conditional and the biconditional are actually constituted by, truth functionally, and are equivalent to combinations of conjunctions, disjunctions, and negations. What's nice about the conditional and the biconditional is that they provide shorthands. So rather than writing out longer sentences, you get to use at various times the conditional and the biconditional. Now, the rules that we learned for deriving the conclusion of a valid argument extend to the intro and elim rules for conditional and biconditional as well. So we have biconditional introduction, biconditional elimination, and conditional introduction and conditional elimination. Now, the two elimination rules, biconditional and conditional elim, involve affirming the antecedent. In other words, when you have a conditional sentence and you affirm the antecedent, you derive the consequent. That's how you dismantle or eliminate the conditional. When you have a biconditional and you affirm the antecedent, you can bring down the consequent. But there is an additional move that you can make. So let's think about it this way. When you affirm the left side of the biconditional, you bring down the right side. When you affirm the right side of the biconditional, you bring down the left side. So it's a two-way affirmation. In both cases, though, again, to remind you, when you eliminate the conditional or the biconditional, you're simply making an affirmation. There's no subproof involved. On the other hand, when you want to generate a conditional claim, you must assume the antecedent of the conditional that you want to derive, and then derive within the subproof the consequent, so that you can assert on the horizontal what you've just proven on the vertical. Namely, assuming I have the antecedent, it follows I've just proven that I have the consequent. So if I have the antecedent, I have the consequent. The same thing goes effectively for the biconditional, but you have two successive subproofs. First, you assume the left side of the biconditional, derive the right, end the subproof, begin the second successive subproof on the same indentation. So assume the right side, derive the left, and then you exit that second subproof and you assert the biconditional. Now, notice what you have in front of you in 8.24 is a conclusion that is a disjunction. So you're not going to assume an antecedent and derive a consequent, or assume a left side and then a right side of the biconditional that you want to prove. Instead, notice that at line 1 you have a disjunction. You already know from chapter 6, when you have a disjunction, you assume the left side, derive the sentence you want, in this case C or D, exit the subproof, then assume the right side of the disjunction, derive the sentence you want, in this case C or D, so that you can exit the subproof and say, I've just proven that whether I have A or I have B, I have C or D. Now, once you have the assumption at line 4, take a look at line 2. Take a look at lines 2 and 4 and look at your conditional elimination rule. 2 and 4 give you 5. You already know from chapter 6 that if you have C or D, you introduce the disjunction. Now, at line 7, what have we affirmed? The antecedent at line 3. 3, 7 gets us D. We've eliminated at line 8, the conditional. And then line 9 gets us, by the introduction of a disjunction, the end of our second subproof. So at line 10, we can say from line 1, 4 to 6 and 7 to 9, which include work done on lines 2 and 3, we have the conclusion, disjunction elimination. Let's check out our work, and we get check marks. All right, now 8.30 is another exercise in which you're given a necessarily true sentence. In this case, it's not the case that if P then Q, if and only if P but not Q. So we want to look at what the conclusion is, which is a biconditional, and we're going to set up biconditional intro, right? So take a look at the fact that from lines 2 through 13, we have the left side of the biconditional that yields the right side. Then from lines 14 through 20, we have the right side yielding the left side. Now, it's a pretty complicated sequence, particularly the first of the two subproof sequences. So lines 2 through 13 give us our original structuring subproof. Then we have a nested subproof from 3 through 11, a double nested subproof from 4 to 9, and hello, a triple nested subproof from 5 to 7. Let's see how we've worked backward from line 13 to get to this triple nested subproof. So we've assumed it's not the case, or sorry, up here at line 2, we've assumed the left side of our biconditional. It's not the case that if P then Q. Now, from that assumption, we need to derive the sentence P and not Q. Well, one way to go about that is working backwards. Assume that your conclusion, P and not Q, is false. That's line 3. What you then need to think about is how you're going to generate a contradiction so that you can get out of the subproof at line 11 so that you are in a position to finish the sequence that is the first half of the biconditional intro sequence. In other words, what you're going to want to do is generate a contradiction that will yield the sentence P and not Q. So, one thing to think about is this. We want to generate a contradiction between line 2, or sorry, let me rephrase that. We want to generate a contradiction to line 2. So that means creating a conditional claim. We also want to generate a contradiction so that this negation at line 3 ends up being eliminated here by line or at line 13. So let's assume we have P. Let's further assume we have not Q. Let's conjoin the two to get P and not Q, which contradicts line 3. That gets us negation intro, not Q, which is eliminated to Q, which gets us P then Q, which contradicts line 2. That means the assumption at line 3 is not the case, and when the negation's eliminated, we get line 13. Take take a look at the sequence starting at line 14. It's considerably less complicated, but there's a double nested subproof in any case, or rephrase, there's a nested subproof in any case. So we assume at line 14, the right side of our biconditional, what do we want? The left side of our biconditional, so that we can get out of the subproof and say from 2 to 13 and 14 to 20, we've proven that when we have the left side of the biconditional, we have the right, and vice versa. All right, so at line 15, we assume the conditional. We eliminate the conjunction at 14, which yields the consequent of the conditional that we assumed at 15. We eliminate the right side of the conjunction at 14, which yields a contradiction, which tells us that our assumption at 15 is not the case, which is exactly the left side of the biconditional. Now, if you can make your way through even part of this pretty comfortably, you continue to work backward, you continue looking for ways to generate contradictions, then you're getting the hang of what we're after in chapters 6 and 8 in terms of some pretty intensive strategic thinking.